Okay, welcome everyone. So the topic that we'll cover today is 8.5, integration by partial fractions. And that's a topic that's, a skill that maybe you have seen in your pre-calculus class or advanced algebra class. But let's start with a little problem here. So let's take an integral, or two integrals in fact. So 4 over 4 minus x squared dx, that is the first one, and that's the second one, so integral of 1 over 2 plus x plus 1 over 2 minus x. Well, and last, let me ask you a question. Which one is easier to solve, evaluate? So I hope you can see, right, that the first one is, I don't know, so we can't do substitution. Yeah, I'm not really sure how I would do this, but the second one looks quite easy, right? It's just log of this minus, I think, log of that, and plus c, right? So I hope you noticed, or you maybe you didn't notice, that these two expressions are actually the same, right? Because if I take the second one, so 1 over 2 plus x plus 1 over 2 minus x, right, then I find the common denominator, right, which is exactly this, so 4 minus x squared, and then here I have 1 times 2 minus x plus 1 times 2 plus x. Right, I'm exactly getting that 4 over 4 minus x squared. Right, we can see that these two expressions are the same, right? This one and this one. So this is what this class is about, right? So we're going to be taking, some rational expression, rational function, and splitting it into two or more simpler expressions, fractions. Okay. Alright, so let's maybe put a little note here. So rational fraction. This is a rational fraction. Alright, it's an expression where numerator is a polynomial and denominator too. Okay, so what we'll be doing, we'll be separating or decomposing those expressions, those fractions. Alright, so we'll take the tools that we have, algebra mostly, tools, and we'll be separating those algebraic fractions or those rational fractions or functions. Okay, so that process is called partial fraction decomposition. Fraction decomposition. Okay, so now let's do an example. Okay, I'm just picking a good one. Okay, let's do this one. So example 1, something like this. So I have this one. 1 over x squared minus 5x plus 6 dx. Okay, so yeah, our job here is to compute this integral, and we'll be doing this by this method. So first step would be factor the denominator. So that x squared, let's factor it here. So x, what is it? Minus 3, x minus 2. Okay, so now what I'll do, that's that's the separation step now, right? So I'll separate these two. So x minus 3 plus some b over x minus 2. So you see I separated them, right, or this fraction into two, and I have one of the factors here in the bottom and the other factor here. What I don't know is what goes up here, right? So that's what I need to find, a and b, and we'll simply just put it on the right try to put it in this form with a and b. Right? So now I'm finding that common denominator, so x minus 3, x minus 2. So I say I need to multiply a by this one plus b by the other one, x minus 3. Okay, so now you see, right, I'm looking at these two, comparing these. So denominator is the same, and for those two expressions to be the same, right, to be equal, 1 needs to be equal to that. Okay, so I'll write it down. So 1 equals a x minus 2 plus b times x minus 3. Okay, so now you see I have one equation and three unknowns, right? So looks pretty difficult, but we're gonna use one fact. So this I don't know, equation must be true for all x's, right? So I'll pick a couple x's, right, and see what happens. I'll pick any x. Oh, let's finish it and make the other, and make the other term disappear. Is it two s's? I have no idea. Alright, so what do I mean? Okay, since I can pick any x, right, well, I'll pick how about 2? So x equals 2. So that's my first pick. Right, and you can see that if I do that, this term will disappear, right? So a times 2 minus 2 plus b times 2 minus 3. Okay, so this is gone, 0, and I have 1 equals 2 minus 3 is negative 1, so negative b. So b equals negative 1. Okay, so we found one of them. Alright, so now we're going to find the second one. And, well, yeah. Let's look at it. So I have my expression over here. So now I pick 2 as my x, as my one of the x's. So now I'll do 3, right? X equals 3, and see what happens. So for x equals 3, I get 1 is equal to 3 minus 2, well, times a, plus b times 3 minus 3. Okay, so you can see this is gone, 0, so a equals 1. Okay, so let me rewrite that decomposed fraction. So I have 1 over x squared minus 5x plus 6 equals 1 over x minus 3, and then b was negative 1, right? So that's why negative 1 over x minus 2. Okay, so let's put it into our integral, because so far we haven't done any calculus, right? Lots of algebra in this section. So x squared minus 5x plus 6. Okay, so that was my original, and this is my decomposed. So 1x minus 3 minus 1 over x minus 2 dx. Alright, so we'll split into two integrals, and we get natural log of x minus 3 minus natural log of x minus 2 plus c. Okay, so the calculus, right? You guys see, calculus was very easy, doable, but the algebra is not that trivial. Anyway, well, it's trivial, but I must say that it is a lot of work. Anyway, let's check out this one. Looks like this. So I have 5x squared plus 20x plus 6, and here I have, let's do something like this. So x cubed plus 2x squared plus x. Okay, quite difficult, right, looking integral, but we have our new tool, right, partial fraction decomposition, and let's use it. So let's factor the bottom. So the top is not going to change, and here I'll have, and if I pull x out, I'm going to get x squared plus 2x plus 1, and that is x plus 1 squared, or x plus 1 times x plus 1. But now watch this. So this is quite it's a little different than what you would expect, maybe. So a over x. So now the second thing what I'll have is the linear factor, so b over x plus 1, and then the last one I need that quadratic factor. Okay, so that's how it's gonna be decomposed. So now we're going to find a common denominator, which is this, right? So x times x plus 1 squared, and that x, right, is missing this, right, whole thing. So I'll have a times x plus 1 squared. Now let's look at b. So b is missing one of those, and x. So b times x plus 1. Okay, and c plus c is missing just x. Okay, so I'll be comparing these two, right? So I have the same denominators, but for this whole expression to be equal to this one, right, I need to make the numerators equal. So let's do that. So I'll have that a times x plus 2. The sun came out. Let's even cover it more. Alright, should work. Okay, so I'm just going to rewrite that. Plus 1 squared plus bx, x plus 1, plus cx, and that equals to this whole numerator plus 20x plus 6. Okay, so what can I do here? Well, I need to pick those x's, right? So my first x maybe will be 0. X equals 0. Okay, so on the left I have 0 plus 1 is just 1, so it's a. It's just a. And then if I put 0 here, that whole term is going to disappear, and the same here, the same thing here. And on the right, if I put 0 here and 0 there, I'm going to get 6. So this is my a. Okay. Another x that I can pick is negative 1. Okay, so let's do that. So I have what do I have? So here on the left I have 0 plus 0, but here I have negative c, right? So negative c equals 5 minus 20 and minus 6. So what is c? Why did I say minus 6? It's plus 6. So it looks like c will be, so negative c equals 11 minus 20, negative 9. So c equals 9. Okay, so we have our c. And we're still missing one. I can use this. One of those variables, b, I think. But we don't have, right, when we look at this equation here, we don't have any more convenient values, right, that we can pick. But maybe I'll use the simplest possible. Maybe just 1 would work. Okay, so x equals 1. So what do I have? I have a times 1 plus 1, 1 plus 1 squared, plus b times 1 times 1 plus 1, and then plus c times 1. And then here I have 5 times 1 squared plus 20 times 1 plus 6. Okay, so you do your arithmetic. A was what? Well, let me actually do this somewhat slowly. So a was 6, right? So I have 6. Well, let me just write this like that. 4a plus 2b and plus c, right? Because what is it? 5, 25, 31. Okay, so a was, I have no idea, 6. So here I'm going to get 24 plus 2 times b. B was, we were looking for b. C was 9. So plus 2b plus 9 equals 31. Okay, so I hope you can solve it for b. B is negative 1. Okay. Alright, so we have our our numerators, right? So our integral that we had was 5x squared plus 20x plus 6 over, what was that? Right here, x cubed plus 2x squared plus x dx. So now we'll have the decomposed fractions. So 6 over x minus 1 here x plus 1, and c was 9, so 9 over that is 1 squared dx. Okay, so I'm going to have 6 natural log of x minus natural log of the bottom, and here the last one we just use power rule, right? So 9 times x plus 1 to the negative 2 power, right? So we're gonna end up with negative 9 times x minus x plus 1 negative 1 power, and eventually, well, you guys see that we can put these together, right? So it's going to be a quotient, so natural log of that 6 is going to be the exponent of x to the 6th over x plus 1. Okay, minus 9 over x plus 1 and plus c. Okay, so you see that the difficult part was working through that algebra, right? Calculus itself was not that difficult. Anyway, let's stop here. And yeah, maybe we'll have 1 or 2 more.